Alright, hello everyone. Welcome back to this week's weekly tutorial. I just want to say very good job on your progress so far in the course. We are here at the final stretch, only 30 days to go, so make sure that you guys get caught up, get those projects turned in, and eventually we'll get to that capstone project and you will get your nanodegree certificate. Move forward in your career as a data engineer. So I'm pleased to announce that I finally got Airflow working on my Windows system. If you watched the last week's video, you could see that I ran into some headache. This has been a 2-week process, and then miraculously I just happened to give it another shot today, and it worked out great. So as you can see here, I'm running Ubuntu through Windows. I will share an article which I followed along to get this working. What you need to do is, this is all log information now, it's not going to be of much help. But yeah, so what you just need to do is you activate Linux shell within Windows. You download Ubuntu. From within Ubuntu, you're going to have to install Python. Then you will proceed to installing pip. From that point on, you'll install Airflow. And then you have to set up the system environment variable within Ubuntu, which will point to your Windows directory, which will contain all of your DAGs and other Airflow information. From that point on, then you can go ahead, you can run Airflow and initdb, and then you are all set. You can go ahead and start Airflow web server, and then you are greeted here by the UI. So today I'm just going to go over some very introductory operators, as well as some other various tools within Airflow that will help you along your data pipeline creation. So let's go ahead and dive in here. So what I want to do first is we're going to take a look here at the bash operator. So first we'll take a look at the documentation here. So you can use the bash operator to execute commands within a bash shell. This is an example here, so we're just saying run this equals bash operator. You define the task ID, which should look familiar by this point. Then here we can go ahead and define a bash command. We set it equal to echo 1, and then you just define the DAG in which you want to run this task. So we'll hop back over here to the Airflow UI, and we'll go ahead and inspect the code here by clicking the lightning bolt in the upper right hand corner. So in order to use the bash operator, we have to import it first. So from airflow.operators.bash operator, we import the bash operator with both capital letters for the first and second word. So here we're just simply defining some arguments that we'll use later. And now here we're defining our DAG, so we set the DAG equal to a DAG. Give it the DAG ID as an example bash operator. Set the default args equal to our args, which were defined up here. We define a schedule interval. And then here's a argument that we can provide. So we can have a DAG run timeout. So if the DAG runs for for way too much time, we can go ahead and set that equal. In this case, we're setting it to 60 minutes, which will automatically shut down the DAG if it runs past that time. So this might be useful if you guys are going to be interacting with AWS services and you maybe plan on running a DAG overnight. It may be wise to set that just in case something goes wrong and you guys start downloading way too much information. You don't want to wake up and find that you now have, a $50 bill with Amazon. Okay, so here we're actually making use of what's called the dummy operator. So this is just for test purposes, just to kind of showcase some of the skills. And to use this, we just go ahead, we can import it here from airflow.operators.dummyOperator. We import the dummy operator. And all you have to do is just define the task ID and the DAG there. So here we're creating a variable called runThis. We're setting it equal to the bash operator, giving it the task ID of run after loop. Then here we're defining the bash command that we actually want to run with this task. In this case, it's echo1. Finally, we just have to define the DAG, which we defined up here, which we named DAG. Now here, we have run this, right caret, then run this last. So this is defining the dependencies. So we have run this is the first thing to be run. Then we have run this last, which is dependent upon run this running first. So now that we have that, we can go ahead, we create this for loop. So we say for I in range of 3. We define the task. Task equals our bash operator. We're setting a task ID equal to run me underscore plus string I. I'll explain this in just a second. Then we have our bash command. We set it equal to echo. And then we have task instance key string and sleep 1. Finally, we have the DAG, which is associated with. So what this is doing is it's doing a for loop. It's running this bash operator 3 times, in effect creating 3 different bash operators, which are representing 3 different tasks. So as I progresses through the first loop, it creates a task ID of run me underscore 0. Then we have the bash command that sleeps for 1 second, and then it's setting the dependency of the task to run this. It goes through the second iteration. I now becomes 1, defines the bash operator, sets the task ID to run me 1, and then once again runs the bash command, sets the dependency. Finally, it goes through a 3rd time. Now I is 2, runs the bash operator, sets the task ID, runs the command, and sets the dependency. So here we have another task called also run this. It's equal to another bash operator. We have the task ID. We have the bash command that we want to run. We set it equal to echo run ID equals the run ID, and DAG run equals DAG run. Finally, we just go ahead and we set up this dependency here of also run this, which runs before run this last. Now here we just go ahead and we say if name equals main dag.cli, which automatically will run the dag.cli when this Python file is run. Okay, let's go ahead and jump back here to the Airflow UI. And now we're going to go over branch operators. Let's look at the documentation here first. Okay, so branch operators. It allows a workflow to branch or follow a path following the execution of the task. It derives the Python operator and expects a Python function that returns a single task ID or list of task IDs to follow. The task IDs returned should point to a task directly downstream from self. All other branches or directly downstream tasks are marked with a state of skipped, so that these paths can't move forward. The skip states are propagated downstream to allow for the DAG state to fill up and the DAG's run state to be inferred. Note that using tasks with depends on past equals true downstream from the branch Python operator is logically unsound, as skip statuses will invariably lead to block tasks that depend on their past successes. Skip states propagates where all directly upstream tasks are skipped. So we'll look over here at the code to get a better sense of what they're talking about there by setting that variable, or I'm sorry, that argument. So here, in order to use the branch Python operator, we need to import it first. In order to do so, we use from.airflow.operators.python operator import branch Python operator. Here we're defining our arguments, which will pass into our DAG. We create a variable for our DAG, naming it DAG equals DAG, DAG ID equals example branch, DOP operator version 3. We set a schedule interval, and then we also define the arguments which we wrote up here. So here we have our first Python function. We're going to print this log statement here, which is going to be executive DTTM equals blank and minute equals blank. We're going to fill those with our quargs here, the execution date and the execution date minute. So if quargs execution date dot minute modulo 2 is equal to 0, so for every even numbered minute, we're going to return task 1. Else, we're going to return task 2. In effect, it's going to branch off dependent on the time of the minute. So here we're going to create a branch Python operator. We're going to set the task ID equal to condition, provide context equal true, which allows us to access those keyword arguments, which we were talking about before, the quargs execution date and the quargs execution date dot minute property. Here we just go ahead, we use our Python callable, which is equal to the should run function which we defined. And then of course we set the DAG equal to the DAG we're working in. So dummy task 1 is a dummy operator. We're just giving it an ID of dummy task 1. Do the same thing for a dummy task 2. And then so here we have our condition, which is our Python operator. We're going to run that first. So dependent on if the minute is even numbered, or here, as you can see, the modulo 2 equals 0, then we run either dummy task 1 or dummy task 2. So it's all dependent on this conditional that we wrote here within our if statement. So this will be useful if you guys are, running some pretty complex data pipelines, in which case if you were doing an HTTP operator and say you don't get any information back, or you don't get enough information back, you would want to have conditions that can actually satisfy your needs dependent on all of these various conditions. Alright, let's jump back here. So we've already gone over the branch operators. Let's take a look at the HTTP operator. Let's see here. Okay, the HTTP operator. So there's a few things to note here. So first of all, it calls an endpoint on an HTTP system to execute an action. So here are the various parameters which it expects. We have the connection ID. We have the endpoint, which is the URL. The method, so we have get or post. Data, so for post / put, depends on the content type parameter. For get, a dictionary of a key value string pair. The data to pass, post data, and post / put, and params in the URL for a get request. Here we have headers, response check, extra options, XCOM push, log response. It's very useful just to go ahead and set that. It expects a boolean, so log response equals true. We'll just go ahead and log to your command. your command line if in fact the HTTP request succeeded or failed, as well as provide other information that might be useful. So let's go ahead and jump into the code here and see what we got. So in order to use the HTTP operator, we have to import it from airflow.operators.http operator import simple HTTP operator. We're also going to make use of the HTTP sensor. So we'll jump back over to the documentation to explain what the sensor does. It's pretty straightforward. It executes an HTTP GET statement and returns false on failure. So basically it's acting as a sensor. So if there is in fact a return from the website, then it will go ahead and proceed with whatever the task is that depends on it. Otherwise, it just returns false. Okay, so we're just defining some default arguments here. We're setting depends on past equal to false. So what that's doing is it's handling the condition when, for example, the HTTP sensor returns a false. We don't always want it to just fail. Oftentimes websites will go down, or for example, maybe certain links are just broken, but we want to continue forward with our data retrieval. So we're setting an email here. We're going to go ahead and set some booleans for email on failure and email on retry. We're going to set one retry for each attempted, for each attempted HTTP request. Here we're setting a delay of 5 minutes. So if the HTTP request fails, Airflow is going to know to go ahead and wait for 5 minutes and then go ahead and retry it just one time. So here we're just defining our DAG. We're going to name it example HTTP operator, and we're going to set the default arguments equal to this right here, which we just went over. Here we're just providing some documentation in a markdown file and setting it equal to __doc__. So now we're going to go ahead, we're going to define some tasks. T1, T2, and T3 are examples of tasks created by instantiating operators. So we just go ahead, we define our task ID equals to postop. Here we have our endpoint, which is the last part of the URL, which we're interested in. Our data is going to be equal to a JSON dumps, and we're going to set priority to 5. Here we have our headers, content type, and application/JSON. So the response check, is it going to be a lambda? So we say lambda response returns true if the length of the response.json is equal to 0, else false. Then we just go ahead and we define the DAG. So if the length of the response.json equals 0, we say the true, else false. Here we're going to go ahead and define our simple HTTP operator. We're going to set the task ID equal to postop for menc. We have an endpoint of node/URL, data name equals Joe. Here we just go ahead and define the headers. What setting the headers do is it's going to go ahead and ignore that first initial header in the JSON document that's returned. Oftentimes you will find that data will have these headers listed in the very top part of the document, and you don't want that to be included in your data. So JSON is basically, you could think of it as a Python dictionary or like a JavaScript object where we have these key value pairs. So we're just saying the content type, and then we have the value, which is the application slash xwww, so on. Okay, so once again, we're defining another simple HTTP operator, T2, setting the task ID as the GET operation. Once again, we have our endpoint. Alright, let me just go ahead and go over this. So we have our method. So in order to define what kind of HTTP request you're doing, you want to define the method. So here we're doing a GET. So we're trying to get information from the website. Other options would be a put. We have delete, and so on. So we're defining our endpoint. We're setting our JSON, our data equal JSON.dumps, and we're going to set the priority to 5. Once again, define the headers of the specific document and then the DAG which it's associated with. Here we're going to do a delete method as our task 4. We have the same endpoint URL. And what this is going to do is it's going to delete some of the data. So finally we have our sensor defined here. So sensor equals HTTP sensor. Our task ID is equal to HTTP sensor check. HTTP connection ID equals HTTP default. Our endpoint is just going to be blank string. Our request params is going to be a dictionary. In this case, we're leaving it blank. So our response check is going to be a lambda function. So if there is a response, set it to true if Google. Else fail. Poke interval equals 5, and our DAG equals DAG. So now we have our dependencies defined here. So first, we try and make the HTTP request using our sensor. If that actually succeeds and we get a response from the website that includes the word Google, then we proceed with task 1. Task 1, if you remember, is a post operation. So we're trying to post some information to the website. If that succeeds, then we go ahead, we do a GET request, which will then basically put some information into the website. Task 3, we have a put. Task 4, we then delete some information. And then finally we wrap it up with task 5. Alright, let's see where we're at here. So this is going to be how you can actually pass in custom parameters on your own in order to run some testing from the Airflow CLI. So in this case, we're going to be using a bash operator and a Python operator. First, we're going to define our DAG, and we're going to name it example passing params via the test command. We set our default arguments and schedule interval, and then the DAG run timeout of 4 minutes. So here we have a Python function called myPyCommand. We're passing to it the kwarg so that we can access these variables from the context. So if kwarg's test mode, so if there is a keyword argument called test mode returned, then we want to print foo was passed in via test command kwarg's params foo equals, and then we're going to return inside of that. So it's going to read as foo was passed in via the test mode, whatever value is returned from kwarg's test mode, quargs params foo is equal to quargs, the value of quargs param foo. So if that fails, then we just print mif was passed in via task params. We're accessing the params keyword and then the object of mif, whatever value is there. And then finally we just return 1. So here we define the command which we actually want to run. So we say my templated command equals echo foo was passed in via airflow CLI test command with value, the params.foo, and echo mif was passed in via bash operator with value params.mif. Here we have our Python operator called run this. Provide the context equals true so that we can access those keyword arguments. Python callable equals the mypy command, which we defined up here. We set the params equal to mif and ag, and set the dag equal to dag. Here we're also making a bash operator, setting the task ID equals to also run this. Our bash command equals my templated command, params equals mif and ag, dag equals dag. So here we want to run this first, and then make also run this dependent upon run this. So if we come over here back to Airflow, we want to visualize this. In our tree, we can see the dependency. So we have our dag defined, run this, and then also run this. So this is useful for when you're trying to run some operations and you want to have your own custom parameters defined so that you can read some information in your log file that otherwise isn't accessible. So you just get a little bit more hands-on customization of possibly some useful information that you want your user or yourself to be able to retrieve from the log files. Okay, so Python operator, we're not going to go over that. We've already covered Python operators pretty in depth. So we're going to go over to the short circuit operator, which is pretty cool operator in case for basic conditions, basically. Very similar to the branch operator, but a little bit differently. So what it does is it allows a workflow to continue only if a condition is met. Otherwise, the workflow short circuits and downstream tasks are skipped. The short circuit operator is derived from the Python operator. It evaluates a condition and short circuits the workflow if the condition is false. Any downstream tasks are marked with a state of skipped. If the condition is true, downstream tasks proceed as normal. So let's say that you're trying to use a Python operator and maybe an HTTP operator, and you're trying to access some data from the internet, and then you want to do some data cleaning within Python. Well, if that URL fails, we can say that now that the DAG will short circuit at that given task, and then we can have another branch basically that will try and access maybe another website to try and get the data that you're after. In which case then another Python operator handles the data cleaning. And you can define as many short circuit operators as you want. Because Airflow basically runs schedule, it's automated service, you want to try and define all of the possible try and take into account all of the possible failures that can happen while these data pipelines are just kind of running automatically. It's very good to try and think of everything that can go wrong and have handle cases for everything that could possibly happen. And that's what the short circuit operator can help you do. So in order to use the short circuit operator, let's take a look here at an example. So in order to use it, once again, it's a derivative of the Python operator. So from airflow.operators.python operator, import the short circuit operator. We have our default arguments defined here. define our DAG, and now, so the condition true task is going to equal a short circuit operator. We give it a task ID of condition is true. Our Python callable is just going to be a simple lambda function that returns true. Then when we have condition false, we have a short circuit operator. Task ID equals condition is false. Our Python callable is lambda false. So D as true equals a dummy operator. Task ID equals true plus string I. DAG equals DAG for I in 1 and 2. Here we have data stream false equals data dummy operator. Task ID equals false plus string I. DAG equals DAG for I in 1 and 2. So what that's doing is just a list expression or list comprehension. Sorry. So we're basically just doing a for loop here 2 times. So for each one of these numbers. So it's saying task ID equals true underscore 1, true underscore 2, and false underscore 1 and false underscore 2. Here we're taking use of the utils.helpers.chain. We're setting the condition true, and then for all of the DS true. And airflow.utils.helpers.chain condition false. So that's an optional way of doing dependencies. Basically just making multiple tasks run within Airflow. Okay, so now we're going to go into the skip DAG. So once again, this is another way of dealing with possible errors within your data pipeline process and handling those cases. As you can see, this is how our tree is defined. So we have our skip operator, always true 1, all successes, final 1. Skip operator, always true, 1 success, final 2. So we have 2 different branches which can handle the possible errors that we may encounter. Let's take a look here at the code. Actually, first let's go ahead and look here at the Airflow schedule exception. I'm sorry, let's see, is that right? Yeah, Airflow skip exception. So it raises when the task should be rescheduled at a later time. Pretty straightforward. Import our DAG and then import the dummy operator just for the sake of this exercise. So here we're just going to create some dummy placeholders. We have a class of dummy skip operator, which has a method inside of it for define execute, and we're going to raise an Airflow skip exception. Here we're defining our create test pipeline. So we have a dummy skip operator. We have another dummy operator that's always true. We have a join of dummy operator. We're setting a trigger rule equal to trigger rule. And then final is our dummy operator. And we have final underscore, which we will pass later on. So either 1 or 2. So we have our dependencies defined here. We have our skip operator, which runs first, and then it goes into join. We have always true, goes into join, and then finally we have our join go into final. So it's 2 branches that meet. If those conditions both run successfully, then we end up in the final node. So here we're just going to run our DAG, or define our DAG, and then we have our create test pipeline. So we run this function, which basically creates all of these tasks. We pass in our suffix, which is 1, our trigger rule, all success, and then we define the DAG which is associated with. we have another one here, create test pipeline, but instead we're just passing in one success. So if one of them fails, it continues to run, and we eventually get to our final task here. Okay, subdag operator. So once again, this is another way of handling multiple branches, multiple data pipelines in case of various events which may hinder your ability to successfully load through the DAG. So a subdag should be prefixed by its parent and a dot, as in parent.child. So it's related to its parent DAG and will run on various conditions that may happen during the data process. Okay, let's take a look at the subdag operator here. So in order to use it, you want to import from airflow.example example dags.subdags.subdag import subdag. Here we're just giving a DAG name, we define our arguments, creating a simple DAG here, we're giving the DAG ID equals DAG name, passing in the default arguments, and setting a schedule interval of once. So here we have a task which is a dummy operator. We're just going to call it start. Now section 1 is our subdag operator. We pass in this task ID equals section 1, and we say subdag equals a subdag of DAG name, section 1, and we pass in the args. The default args equals args, DAG equals DAG. Some other task is another dummy operator, and then we have section 2, another subdag. Once again, we set our subdag equals subdag, DAG name, pass in the task ID, section 2, and then we pass in our args. Remember, our args were just up here. It's the owner airflow and our start date. So default args equals args, DAG equals DAG, and then finally we have our end, which is another dummy operator, which represents what we want to do with all of this information once we reach the final stage of our DAG. So here's our dependencies. We start, we run through section 1, which then goes to some other task, which then goes to section 2 and ends. Now let's see here, guys. We have time for about one more here. So we're going to go into the trigger controller DAG. So trigger DAG run operator. Once again, this is also in the realm of handling different conditions which may occur in your automated pipelines. So I'm importing PrettyPrint here. PrettyPrint was just a nice way of formatting your log files and making it a lot easier to, look through all that information. As you know, the Airflow document or Airflow log files do contain a lot of information, and it's kind of hard to narrow down exactly where you can find that information that is actually relevant to you. So here I'm just saying PrettyPrint, our PP equals prettyprint.prettyprinter, and we're setting our indent equals to 4, which is just going to provide some nice formatting for our log file. Here I'm defining a function called conditionally trigger, passing in the context, and then we have our second parameter, which is DAG run object. So C underscore C. So this function decides whether or not to trigger the remote DAG. So our context, params, and then the condition param. So whatever that value is will determine if we want to run that remote DAG. We parent controller DAG, conditionally trigger equals that, and then the result of that that quark that we passed up here from the context. So if context params condition param is true, then we want to run this. dag run object.payload equals message context params message, so the value of these. Then we just want to go ahead and pretty print our dag run object.payload and return that. Here we just define the dag, giving it a schedule interval of once. Now here we just define the simple task in the controller example. So trigger equals trigger dag run operator. Task ID equals test trigger dag run. Our trigger dag ID is example trigger target dag. We pass it the conditionally trigger function, which we defined up there. And we set the params equal to the condition param true, message hello world. So what this is going to do, it passes the conditional trigger function. Since we're passing in the value of true to condition param, this if statement up here will return true, and then it goes ahead and it continues on with the rest of this code here, which returns the pretty printed payload. Otherwise, this will not run and we will not see this message that is conveyed. Alright guys, so that wraps it up. Please go ahead and check in the description. I'm going to share the website, which I found very helpful in getting me Ubuntu running Airflow on my Windows 10 system. If you're like myself and you refuse to use anything but Windows, old habits die hard, then this will be instrumental for you in order to get Airflow up and running. Once again, great work as you progress through the course, and just to remind you, we are here at the 1 month deadline, and I hope that you guys feel free to reach out to me if you have any issues getting these projects in. I'm here to help, and I want to make sure that you guys succeed. Anyways, until next week, take care.